Unit 1B, Lesson 1, Using Units to Solve Problems. So in this lesson, we're going to start with 1 unit of measurement and go through the process of converting it to a desired unit of measurement. Okay, the process we're going to use is called the railroad track method. You use conversions a lot in science classes. Now to the first example. Peyton is a sprinter who can run the 40-yard dash in 4.5 seconds. He converts his speed into miles per hour as shown below. So we can see the process he went through to convert from yards per second to miles per hour. So we want to determine which ratio is incorrectly written to convert his speed. The first thing I did was break apart each step. I broke apart the numerator and the denominator, and also each step going left to right. So now we can see why this is sometimes called the railroad track method. So when we're trying to convert, if we're starting with yards in the numerator, if we're trying to get rid of that, we have to make sure our yards are in the denominator somewhere along the line. Because if we have a yard unit in the numerator and denominator, anything divided by itself is going to cancel out. And we also know there's 3 feet per 1 yard, so that's why we can use this conversion. 3 feet and 1 yard are equivalent. So our yards and yards cancel out. The next step, we want to convert feet into miles. Well, here we can see there's already a mistake because we have feet in the numerator, and in our next conversion, we have feet in the numerator as well. That feet should be in the denominator. Okay, so we can see right away this is our conversion. That's going to be incorrect. So it would be number 2 down below. It should be flip the reciprocal. 1 mile per every 5,280 feet. If we continued on, we could see that our seconds and seconds would cancel out. Our minutes and minutes would cancel out. So we could see our time is correct. We have per 1 hour. It's just this conversion that was wrong. Now to the second example. A construction worker needs to move 120 cubic feet of dirt by using a wheelbarrow. One wheelbarrow load holds 8 cubic feet of dirt, and each load takes him 10 minutes to complete. One correct way to figure out the number of hours he would need to complete the job, or this job, is, so we know we start with 120 cubic feet. We know one wheelbarrow load holds 8 cubic feet of dirt, and each load takes him 10 minutes to complete. So we want to determine how many hours it would take him to complete this job. We have to determine which conversion is correct. So when looking at the options we have, all of them start with 120 cubic feet over 1. So the first thing I would do is try to convert the cubic feet into 1 load. Okay, so if my cubic feet is in the numerator, I know somewhere along the line there has to be a cubic feet unit in the denominator, which in the first one it is. If we look at our second one, we have cubic feet in the numerator and cubic feet in the numerator. Those units will not cancel out, so I know that I can't use number 2 that is written incorrectly with our conversions. Number 3 is also written incorrectly because there's cubic feet in the numerator and numerator. It will never cancel out. Then number 4, cubic feet in the numerator and denominator. So right away, just that first step, we can see that we only have options 1 and 4 left. So now we have to determine which of these 2 is correct. So I'm going to start canceling out some units. I know my feet cubed and feet cubed are going to cancel out. It takes 1 load. Every 1 load takes 10 minutes. So those cancel out the loads. So now I'm left with minutes squared. I have minutes times minutes. So minutes squared over 1 hour. We want to just determine the number of hours. So this one is also written incorrectly because this should be the reciprocal. It should be 1 hour per every 60 minutes. So number 1 is not going to work. So now let's check number 4 to make sure it works. Feet cubed and feet cubed cancel out. The load and the load cancel out. Minutes and minutes are going to cancel out. So the only unit we're left with is hours, which is what we want in the end. So number 4 would be the correct answer. Now to the last example. The formula C equals 5/9 times a quantity F minus 32 is used to convert Fahrenheit temperatures F to Celsius temperature C. What temperature in degrees Fahrenheit is equivalent to a temperature of 10 degrees Celsius? So there's a couple different ways we can solve this problem. We can substitute 10 degrees in for Celsius right away because we're looking for the Fahrenheit temperature when the temperature is 10 degrees Celsius. Or we can isolate F by itself first. Once we get F isolated by itself, then we can substitute 10 in for C. Okay, it doesn't matter. I'm going to choose to isolate F by itself first. So in order to get F isolated by itself, the Fahrenheit temperature, we have to get rid of this 5/9. Okay, so we're multiplying this quantity by 5/9. So we could divide by 5/9, the inverse order of operation. Or to get rid of a fraction, instead of dividing by a fraction, we can multiply by the reciprocal. So we can multiply by 9/5. If we multiply the right side, we have to multiply the left side by 9/5 as well. So 5/9 times 9/5 is 1. So now on the left side, we have 9/5 times our Celsius equal to F minus 32. Now the last step would be add 32 to the other side. And we're left with 9/5 times our Celsius temperature plus 32, that was a good plus sign, is equal to our Fahrenheit temperature. Now the last step is to substitute 10 in for our Celsius temperature. So off to the right, I finished this conversion. We have F is equal to 9/5 times 10 plus 32. Well, if we take 10 divided by 5, that's 2. 2 times 9 is 18. So 18 plus 32 gets us 50. So we determined that 10 degrees Celsius converts to 50 degrees Fahrenheit. So in this lesson, we dealt with conversions. The main idea you need to remember is the railroad track concept for converting. If you're trying to convert from one unit to the other, if you want units to cancel out, you must have a unit in the numerator and denominator in order for those to cancel out.